Okay. So the fundamental accounting principle just basically means how many ways can it's a how do you calculate how many ways something can happen given certain constraints? So if you have, if you're just talking about one task and there's 5 ways to do that task, then obviously there's 5 ways to do that task. But if there's 5 ways to do one task, and let's say 6 ways to do some other task, call them tasks M and N, and you wanted to know how many different ways are there to perform both tasks together, either consecutively in either order, right? It's going to be M times N. So in this case, it would be 5 times 6, so there'd be 30 ways altogether to do the two tasks, assuming they're independent, right? Meaning that however I do task 1 doesn't affect how many options I have to do task 2, right? So if they're like completely separate, independent things, you would just multiply the number of options you have at each step, and that will give you the total number of ways to perform those two tasks together. So just as a warm up here, we'll take like a minute and a half, maybe 2. I don't even think you'll need that, but just take a minute and read that. And when you think you have an answer, put it in the chat. All right, so a bunch of people saying 3 in the chat. 3 is the correct answer. I know we don't know each other. We all just met 5 minutes ago, but does anybody feel comfortable sharing how they got to that answer? Want to come off mute and just talk me through your process here? 3 is the right answer, so nobody's going to be embarrassed if you explain how you got to 3. All right, a little shy. All right, I'll do the first one. So, okay, first things first, always just read the whole problem, including the answer choices, right? So doing the GMAT problem, really just any kind of GMAT quant problem, and really just any kind of quant problem. This is like, they've proven this by sticking people in MRI or CAT scan machines and having them do math problems. And broadly speaking, your brain lights up in 4 distinct regions in a distinct series. And layman's terms, you have to read the thing, you have to think about how to do it, then you're going to go about solving it. And last but not least, you answer the question. But what that means is, first things first, just read the whole question. Don't read, just to hear and say, okay, I got to write down 72, and then 2 and 3 and 4 and X, and like decide, okay, I guess I'm going to do algebra here or something. Just don't write anything down until you've read the whole problem, including the answer choices. The answer choices are a very underutilized resource on GMAT quant questions because it's multiple choice. The answers are on the screen. The right answer is there. It's on the screen. So I think a bad habit a lot of people have is they get here and then they immediately start working, right? And then they get to an answer and then they finally look at the answer choices and they pick, hopefully they got an answer that is in here. And if you're right, great, but maybe there was a faster way to do it, but potentially by using it. So in any case, read the whole thing, think about how you want to set it up, give yourself an opportunity to think about, there's probably more than one good way to do it. Then once you've decided, okay, how am I going to actually do this? Then go do it, solve it, and then finally get your answer. Make sure you're answering the right question, because very often you might have done everything correctly, get to a number, that number's accurate, but it's not what they asked you for, right? So just all kinds of little habits that can help get us closer to the right answer and less likely to make a mistake. So in this case, relatively straightforward problem, 72 possible outfits, 2 belts, 3 ties, 4 shirts, and X pairs of pants. So this is just the fundamental accounting principle of we've got 2 ways to choose a belt, 3 ways to choose a tie, 4 ways to choose a shirt, and X ways to choose pants. And they're telling us that the total number of possible ways to make an outfit is 72. So this is just 2 times 3 times 4 times whatever X is. And that's what we're solving for. How many pairs of pants? So it's just set this up, solve it. Always write down your goal. We are looking for X. So 2 times 3, 6, 6 times 4, 24. So this is 4X equals 72. Divide both sides by 24. X equals 72 divided by 24 is 3. And that is the right answer. Alternatively, we could have, if you hate doing algebra, you could just plug in 2 or 3 or 4 or 6 and pretty quickly recognize like, oh, yeah, if I do 2 times 3 times 4 times 3, that's going to give me 72. 2 times 3 times 4 times 2 is not going to work, etc. Okay. Just pretty simple warm up there. Any questions or comments before I move on to the next one? Okay. All right, they get more interesting from here. Okay, so now let's talk about permutations and combinations. Because it's important to understand the distinction between them, what they share in common, and then the key differences between them. So broadly speaking, a permutation is anything where the arrangement of the items, order of the items matters, meaning if we change the order, even if we have the same items, we change the order they're in, that counts as a different permutation. So for instance, how many 3-letter permutations of A, B, and C can you make with no repeats? So you can't do AA or BB. You just have to use each letter once. And that's the answer to that is 6, because here they are. There's just 6 different ways we can shuffle those letters up: ABC, ACB, BAC, etc. So that's a permutation. The order, right? Because just by changing the order of C and B here, this makes these 2 different permutations. Contrast that with a combination. A combination is really just what are the items in our grouping, in our combination, and it doesn't matter what order. So how many 3-letter combinations of A and B and C are there? Again, if we're not repeating any, the answer to that is just 1. It's just A and B and C in whatever order. So all 6 of these essentially would get collapsed or flattened into just one single possible combination. Okay. Stop me if you have any questions, either I'm monitoring chat or just want to jump off mute. But okay, so far so good. And there are going to be different approaches, or related. They're essentially versions of each other. But when you're doing a GMAT problem like this, you really have to, one of the first things you want to ask yourself is this a permutation problem or is it a combination problem? Because that's going to inform how you do it. All right, so quick question. What is that called? What do we call that? And what should we call it? What kind of block is that? So Tony says combination. Some people say permutation. Yeah, we call it a combination block. I mean, that's what it's called. If you think I got this picture off Amazon or something, like master combination lock, right? But why should it be called a permutation lock? Just gonna cold call somebody. Ava, why should this be called a permutation lock?
The order of the values matter.
Right. Like if your locker combination is 4, 19, 10, you got to put those numbers in that order, right? So it doesn't work if you do 19, 10, 4, even though that would be the same combination of those 3 numbers. Okay. So yeah, this should be called a permutation lock mathematically. It's not, but for the purposes of the GMAT, you want to keep these things straight in your head. So that's, I think it's a kind of fun way to stick it in your head. So it's like, yeah, no, this ought to be called a permutation line. Okay. So now if we're doing a combination, here's the basic combination formula. We're going to use this formula for the next 45 minutes a few times. And so you should memorize this or just, write it down on a flashcard or whatever. And some of you might remember this from high school or maybe middle school, whenever. So this would be if we're trying to figure out, how many ways could you choose K items from among N total items. And we don't care about the order of those items. So the formula would be N factorial divided by K factorial times parentheses N minus K factorial, where N is the total number of items to choose from. K is the subset of numbers, the items that we're actually going to pick out of those N total items. Okay. But let's see if we can figure out why that's the formula and what makes it distinct from the permutation formula, which is very close. So let's work through some examples here. So let's say you're planning a weekend movie marathon. You've got 8 movies lined up in your whatever streaming service of your choice, your queue. How many different ways or orders could you watch all 8 movies in? So in this case, the order does matter. So first of all, is this a permutation or a combination?
Permutation.
This is permutation, right? Because I said order matters. Okay. So I've got 8 time slots. 3, 4, 5, 6, 7, 8. I've got 8 movies to choose from. So for my first movie, I have any of the 8 movies. Now, once I watch that, whatever movie I ended up picking out of the 8, since I can only watch each movie once, I can't watch that movie again. So for my second choice, my second movie, I only have 7 movies to choose from. And then once I watch that second movie, now I only have 6 remaining movies to choose from. 5 and 4 and 3 and 2. And when I get to that last movie, there's only 1 movie left. So essentially it forces me to choose that last movie. So 8 ways to choose the first movie, 7 to choose the second movie, 6, and on and on and on. And fundamental counting principle, I just multiply these. Okay, so that's 8 factorial. It's a big number, whatever it is. But that's a lot of ways to come up with an 8 movie marathon. Okay. Now, so that's broadly speaking, just N factorial ways to order N items. Okay. Now, let's say we don't have time to watch all of it. So we're just going to watch 3 out of the 8 movies. How many different ways could we watch just 3 of those 8 movies? Again, where the order matters, right? I'm making a schedule here, so I care about what order the movies are going to be in. So instead of having 8 time slots to fill, I only have 3 time slots. Well, for the first time slot, I got 8 movies to choose from. For the second time slot, I only have 7. For the third, I only have 6. And then I stop. So that's it. And whatever that is, it's not nearly as big of a number, but it's still a pretty big number. If you have a calculator, feel free to tell me what that number is. I've never bothered actually calculating because that's the point here. But here's the formula for what that is. This is N factorial. So where N is 8 and K is 3. Right? So what we just did was we started counting down N factorial, but then we stopped after we got to the third one. So in the denominator is N minus K parentheses factorial, because what that does is if you have N factorial and you go all the way down, like we did in the previous example, what the bottom does is this is basically 8 factorial over 5 factorial. So this becomes 5, 4, 3, 2, 1. This is just there to cut off the tail by canceling out everything from 5 on down, because we really are just interested in the first 3 choices that we made, and then we stopped. Okay. So this is the permutation formula. So not just a little tired. I'll try to spice it up for you. Okay. Any questions about that? So this again is a permutation. This is kind of the permutation formula for choosing k items from n items. Okay. Now, let's say 8 movies to choose from. We're just going to watch 3 movies. But now we realize I don't really care what order those 3 movies are in. I'm more interested in how many different groups of 3 movies I could come up with, whatever order I watch those 3 movies in, right? So now this is not a permutation anymore. This is a combination because the order of the 3 movies doesn't matter. So this is where the combinations formula I showed you on the last slide is going to come in. But all that is what we were doing before. So we start counting down from 8, 7, 6. We stop after we do the first 3. So that's the n minus k factorial, right? But then also, for each of those groupings that we came up with in this example, like let's say in this example, we had, let's say our 8 movies were A, B, C, D, E, F, G, whatever the 8th letter, H, I guess, is that 8 letters, right? A, B, C, and C, B, and B, and C, and B, C, A, and C, A, B, and C, B, A would all count as 6 different permutations in this example up here. But down here, we only really care about just A and B and C in any order. So in order to basically convert from this all the way down to just this for every group of 6 permutations of 6 that are really just combinations of 1, we need to divide by 3 factorial. Because that 3 factorial is how many different ways could you put the 3 movies that you picked in order, which is 6. So this is the combinations formula. Okay, everybody see this? And then that becomes 56 because it's 8 times 7 times 6 over, well, here, let's times 5 factorial over 3 factorial. 5 factorial, 5 factorials cancel out there, and then 3 factorial is just 6, so that cancels out that 6. So 8 times 7 is 56. Okay? So if the order matters, it's a permutation, like in these examples. If the order of the items does not matter, it's a combination, in which case you're going to use this form. But it's really all just different. It's like layers of the same. Any questions? Okay, well, let's see how it works in some full problems.
A quick question.
Oh, yeah, what's up?
Will most is a tagline regardless of order, is that going to most likely appear in most questions for us to identify when it's once combination or a permutation?
You're asking like how will you know?
Yeah, like is it usually some kind of like wording like that specifically?
Generally not. Well, let's look at a couple together, but it's more like contextual. Like if they're talking about a code, for a door or something, then would that be a permutation or a combination? Like a keypad code or something to unlock a safe. What would that be?
Yeah, permutation.
That'd be a permutation, right? But so here, let's look at this next one. So this is one where 10 people are in the running to be on an 8-person team. Just for that part, then there's this whole thing about selecting a captain, which we're going to have to figure out. But just for the first piece, 10 people, and we're going to choose 8 people from those 10 people to be on a debate team. If you're on the team, it doesn't really matter what order there's no hierarchy on the team other than this captain thing. Figure out, okay? But that first piece is just a combination, okay? So it's contextual like that. All right, so let me give you like 2 minutes to try that. All right. If you have an answer, put it in the chat. Like a couple people said, one person said 45, a couple people saying 360. Yeah, so the answer is 360. But looks like most people didn't put answers in. Maybe you're just not feeling ready to share your answers with the group yet. That's okay. Or maybe you were stumped. I'm gonna, if there are any volunteers, they can talk me through how they got to 360. That's great. But before we do that, I want to talk about just again how what to do if you're not sure on a situation like this. So there, as I sort of alluded to at the beginning, there's really two pieces to this problem. There's this 10 people, and we need to choose 8 of them to be on this debate team, and that's going to be a combination. And then there's this other piece about picking a captain from somebody on the team. Let's just focus in on the picking a captain piece. So we have to color coding. So it's like pick 8 people from 10 people, and then and pick 1 captain from 8 people. Well, can anybody, how many ways are there to pick 1 captain from 8 people? So we just focus on this part for a second. Like think back to the belts and shoes and shirt problem. There's just 8, right? Okay. So that piece is 8. And whatever number is here, whatever we get for that, what are we going to do with these 2 numbers once we have them? How are we going to combine those numbers? Add, subtract, multiply, divide. We're going to multiply. Okay. So it's going to be something times 8. Okay. Let's say that's as much as you could figure out about this problem. You didn't remember the combinations formula because it was in your short-term memory from 5 minutes ago, and it's already fallen out of your short-term memory. Is there any way to get this problem right, or at least get closer to the right answer? Yeah, deep D. Yeah, see which answers can be divided by 8 are multiples of 8, right? Because the right answer should be something times 8. And this obviously is going to be like a whole number, integer. So it should be an integer times 8, which means this answer should be a multiple of 8. Well, let's see. 45, is that a multiple of 8? No. So I don't think that's going to be the answer. 90, that's not a multiple of 8 because 80 is multiple of 8, and then 88 would be the next one. So no. 270. So I know 240 is multiple of 8, and then 30 more than that, but 30 is not a multiple of 8. So 240 plus 30. So that's not going to be a multiple of 8. 360. Well, we know the answer is 360, and yes, it is divisible by 8 because 320, right? And then 40 more, and 40 is 8 times 5, so that could be it. And then 450, well, 400 is definitely a multiple of 8. 50 is not a multiple of 8, so 450 is not a multiple of 8. So, oh, even if you don't know how to do half of this problem, you can still get it right. Okay, and that's that's not always going to work, but it'll work sometimes. Or maybe you could get it down to 2 answers that way. Those are the sorts of things that you really want to have in your back pocket to be able to answer a question, even if you don't really know how to do the question. Okay, just you can still maybe get it right, or maybe get from 5 choices down to like 2 choices or 3 choices, which is going to really increase the likelihood that you guess correctly. Okay, so now let's talk about how to actually solve the rest of this problem. So any volunteers? No, I'll just call on somebody. How about Tony Kim?
So it was a combination of so it's 10C8. So I did 10 factorial divided by 10 minus 8 factorial times 8 factorial to get to find the combinations of 8 people from 10, and then I multiply that by the 8 that we got for picking one captain.
Right. So the 8 factorial cancels out with that 8 factorial, and we got 2 factorial down there. So that's 10 times 9 over 2. So that's 90 over 2, which is 45. So yeah, there's 45 ways to pick 8 people from 10 people, where we don't care what order those 8 people are in. That's what makes it a combination. Order does not matter. And then for every one of those 45 possible combinations, there's 8 potential captains to pick. So that's why it's multiplicative, 45 times 8. And 60. Okay. Any questions there? Okay. Let's keep going. All right, try that. All right. Several people got answers in. 7,000 seems to be the most popular answer. That is the correct answer. Anybody want to share how they got there?
I can go.
Yep, sure, Prim.
So I set it up as 3 different combinations
Mm-hmm.
for each group. So each group would be set up using the equation. I don't know if I'm gonna say it out, but
Yeah, I mean, I'll just write it down.
okay, it's so the first group of Arabic translators is 6 factorial over 3 factorial times 3 factorial.
Right, so for Arabic, it's 6 choose 3. So 6 factorial over 3 factorial, 3 factorial.
Yeah. And then the next group is German, so it's going to be set up as 7 factorial. Sorry, like n equals 7, k
Right.
equals 3. So it'll be 7 factorial over 3 factorial times 4 factorial. Last group is Swahili. So n equals 5, k equals 3. You have 5 factorial over 3 factorial times 2 factorial. then you're gonna multiply these three groups at the and then
Yeah.
yeah.
Yeah. Why multiply?
Because I don't know. I know, yeah.
Okay. Well, so you're right, and your intuition is right. So let's just finish it out. So so this is going to be like 6 times 5 times 4. That cancels out with one of the 3 factorials, and the other 3 factorial is just a 6. So that cancels out with that. So this one is, well, I probably should have done that in matching color, but anyway, yeah. So that first one is 20. This second one is 7, 6, 5. Cancels out with that 4 factorial. Then again, 3 factorial is just 6. So that cancels out there. So that's 35. And then this one's 5 times 4. Cancels out 3 factorial over 2. So that's 20 over 2. So that's 10. So 20 times 35 times 10, or 20 times 350, 2 times 35, 70, 2 more zeros. There you go, 7,000. So any questions there? Or, well, so does anyone want to take a stab at explaining, yeah, why is this, again, multiplicative? Why are we multiplying these numbers by each other? So the easiest way to know that we should be multiplying here is that, again, think of it just like the first example we did with the belts and the socks, right? And the use of the word and. Okay, the team of translators includes 3 Arabic translators and 3 German translators and 3 Swahili translators. So what we just calculated was there's 20 ways to pick the Arabic translator. And there's 35 ways to choose the German translators. And there's 10 ways to choose the Swahili translators. And we're going to do all of them. But we have to do the Arabic choices and the German choices and the Swahili choices. So that's why it's multiplicative, just like we were choosing, we have to choose a belt and we have to choose a shirt and we have to choose a pair of pants. We're multiplying those. Okay. There you go. 7,000. If it was or instead of and, we would add the combinations. Yes. And so let's look at this next problem. Potentially relevant hint. All right, try that. All right, people are putting in answers, and 37 is the right answer. So, anybody want to share how they got there?
So you basically have the same thing as the last problem. It's a combination,
Right.
but now you add.
Right. And then for the last step, we're going to add them. And Jorge, why in this case do we add them?
Well, because they use the word or.
Right. But what? Okay, so let's just go through the steps and then let's make sure I mean, you're right. Yeah. If we see the word and, like, probably going to multiply. If we see the word or, probably going to add instead of multiply. But I mean, you know, I don't want you to be like robotic again. Like, obviously the word and is there. But in any case, okay, so we got like burgers, we got pizza, and yes, this problem makes me hungry. Hot dogs. All right, so it's 5 types of burgers, 7 kind of pizza, 4 different kind of hot dogs, and K in each case is 2. So it's choosing 2 for the 3 different types of food. This is going to be, okay, factorial over K factorial and K factorial. This is going to be 5 factorial over 2 factorial, 3 factorial. By the way, little side note there is like the way this works, since it's n and then k and then n minus k, these two, like whatever you get here and here, always add up to what's up here. Not that 2 factorial and 3 factorial add up to 5 factorial. That's not the way factorial works. But like 2 and 3 add up to 5 because k and n minus k add up to n, right? So if when I'm setting these up, it's just a little bit faster. You know, once you get comfortable using the formula, you can just go like, all right, 7 factorial, 2 factorial, 5 factorial, right? So you don't have to write like 7 minus 2 and change it to 5. Well, you can if you want to. And then it's 4 factorial, 2 factorial, 2 factorial. So then we have 5 times 4. Then we cancel the tail with the 3 factorial over 2. So that's 20 over 2. So that's 10. This is 7 times 6. 5 factorial cancels out over 2. So that's 21. And this is 4 times 3. Cancel out 2 factorial over 2. So that's 12 divided by 2. So that's 6. And then here we go. We're going to add these to get 37 because, okay, it says or here and here, but why? Why mathematically are we not doing the fundamental counting principle anymore of just multiplying at each step? Bishma says each choice by itself is sufficient, meaning like each of these 10 ways, like if we decide to get the burgers and there's 10 ways to choose the burgers, and then that's it. Like once we've chosen some burgers, we're done. We're not ordering any more food. Or we would choose pizza, and there's 21 ways to choose the pizza. And if we choose pizza, then we're not choosing burgers, and we're also not choosing hot dogs. So we're done, right? Or alternatively, if we want to choose hot dogs, there's 6 ways to do that, right? So whereas in the previous examples, we were making some choices, and then we were following that up by making some more choices, and then maybe some more choices, right? It's multiplicative because, like, if you, let's say we're, you know, let's say like choose a letter. Yeah, here, so choose a letter. Here, I'll make it 4 number. Choose a letter and a number. All right, just a little example here. If I give you these 3 letters and these 4 numbers to choose from, and I say choose a letter and a number, I got 3 ways to choose a letter. I got 4 ways to choose a number. So that's going to be 3 times 4, 12 ways to choose a letter and a number, because it could be A1, A2, A3, A4, that's 4, or B1, B2, B3, B4, that's 4 more, or C1, C2, C3, C4, that's 4 more, that's 12 total ways, right? But if I had instead said, choose a letter or a letter, a number, well, then it's just choose a letter, A or B or C, or choose a number, 1 or 2 or 3 or 4. And so there's just 3 ways to choose a letter, or there's 4 ways to choose a number, and there's 7 total ways to choose a letter or a number. That's it. Okay. So yes, the key tell or the clue here is going to be the word or versus the word and. But it's always important that you understand like why that's what the math is doing. Okay. Any other questions there? Okay. Got about 15 minutes left here. All right, so now let's talk about restrictions. I'll give you a hint here. So again, this is going to be a combination problem, but now they're giving us a restriction. See if you can figure out how to do the problem ignoring the restriction, and then figure out what the relationship between that unrestricted version would be versus this restricted situation that they're telling us that we need to avoid. Okay, about 2 minutes there. All right, looks like most people might be a little stumped here. Only one person has an answer in. Ruaj, hope I'm saying that correctly. That is the right answer. So, Ruaj, you want to share how you got there?
Yeah, for sure. So I was just thinking, since it says that 2 students refused, I was thinking of the scenarios in which, like, the combination would happen. So one would be when both those students aren't part of the team. That means we have a pool of 7 candidates to choose from, and we choose 5 from that. So that'd be 7C5. And then another scenario would be if one of them was selected And then we know that if one of them was selected, the other one wasn't gonna, be part of the team. So it would be 1C1 multiplied by, again, like 9 minus 2, 7. And out of that, we would need like to choose 4 people
Right.
because
Sorry, let me just pause because I want to make sure I'm following this correctly, and then I'll be scribing for this. So you're figuring out how many ways we can make this team without having both of them on the team together, right? So you
that would be
started
one of the scenarios, like one of the
right,
scenarios.
or one or the other, right? So you're trying to
Yes.
avoid having. Okay, great. So you're doing it this way. You're basically doing it from the bottom up, and this is a good way to do it. Okay, cool. So I just want to make sure I was hearing that correctly. So let's talk through this. So basically, let's just jot this down. So we got 9 total students. We need to choose 5, but we got these 2 hate each other. Okay, so basically it's like, how could we make these teams and avoid having the 2 who hate each other be on the same team? So you said one way is just neither one of them's on the team.
Yes. So
right?
that'd be 7C5.
Neither one is on team. So that's really, so we're just going to exclude them together, all together, right? And here, let's call these, I don't know, like 1, 2, 3, 4, 5, 6, 7, N for nice people, and H for the 2 haters who hate each other. So if neither H is on the team, then we have 7 to choose from. And we're going to choose how many?
5.
5, right? Then it's fine. Neither of the haters on the team. Cool. So that's going to be 7 factorial over 5 factorial, 2 factorial. Okay. Then what's the other possible scenario we can do here?
That'd be if one of them was selected, and that would be just 1C1 because one person selected. And then we know that if that person is selected, the other person is not going to be on that team at all. So
Right.
again, our pool would be out of 7 people, but we'd only need to select 4 people because we have already selected 1 person.
Exactly. So now we have 7. We have the 7 nice people to choose from. But now we're only going to pick 4 of them. So that's 7 factorial over 4 factorial, 3 factorial. Okay. And then what?
Then it would be the case if like the other person got selected, then it'd be like the same scenario again. So instead of like doing the same math again, I just, because in the end we'd have to add all of these, right? So I just decided to multiply the second combination.
Yeah, so there's a couple ways you could think about this. It's like if we say we pick, let's call them H1 and H2, right? We could say that, originally we said, let's just put H1 on the team, and then therefore H2 is not going to be on the team. So H1's on the team. Now we got to pick 4 other people out of the 7 nice people to put on the team with H1. And there's this many ways to do that, whatever. We'll do the math in a second. But then the other version is we put H2 on the team instead, and then that's the same math, right? So we would just double that. So yeah, or you could think of it as pick which one of the 2 haters would make the team, which would just be times 2. So you could do it any number of ways, right? But basically it's this times 2. Pick 1 H out of 2 haters. So this then becomes 7 times 6, cancel out the 5 factorial over 2. So that's 42 over 2. So that's 21. And then this is 2 times 7 times 6 times 5, cancels out the 4 factorial over 6 with the 3 factorial on the bottom. So that cancels out with that. So that's 7 times 5 times 2. So that's 35 times 2 is 70. And then our last step is we add them. And why are we adding them here? Rawash?
Because it's not like, because in the end they're all going to be the same team, right? We are just looking at the number of possibilities.
Yeah, it's we're not like doing this and then we're doing this. We're doing one
Right.
or the other, right? So it's
Right.
this or that. So we're just gonna add them. So it's 9. Okay. So that's a combinations with restrictions. Now, there's another way to do this and so this was a very good way to do it, perfectly logical. Let me show you the way it's mostly the same, but it's sort of coming at it from the opposite direction. This is instead of sort of building it up from the ground up and like coloring within the lines and figuring out, okay, we could have, what kinds of teams are allowed. The team, we could do a team where neither one of the haters is on the team. That's allowed. Or we could do a team where one of the haters is on the team. That's allowed. Or we could do a team where the other one of the haters is on the team. That's also allowed, right? That's like 3 different scenarios we have to come up with. A little bit simpler is instead of doing it that way, let's just figure out what's unrestricted. Just imagine everybody got along and it was just, hey, we're just going to pick 5 out of 9 people and nobody hates each other. Well, what would that be? Just be 9 factorial over 5 factorial, 4 factorial. But then, okay, let's take away any teams that aren't allowed. So what kind of team isn't allowed? The only team that isn't allowed is the team where the 2 haters are both on the team. So if we put both haters on the team, right? So that's 2 people. Then we need how many more people to make a team, to make the rest of the team?
3.
3. We need 3 more people, right? Out of the remaining 7. So pick 3 out of 7. And so this would be 7 factorial over 3 factorial, 4 factorial. So let's see what happens here. This is 9, 8, 7, 6. Cancels out 5 factorial, 4, 3, 2, 1. 4 and 2 cancel out with 8. 3 and 6 cancels out to just 2. So that's 9 times 7 times 2. And then this is 7 times 6 times 5 cancels out 4 factorial over 6, 3 factorial. So that's that. So that's 35. So what is this? This is 63 times 2. So 126. I hope I'm doing my math correctly, right? So there's 126 like unrestricted ways, just total, just without any rules. There's 126 ways to pick 5 people out of 9 people, and then there's 35 disallowed ways within that 126. So the last step is we just subtract the disallowed ways from the total number of unrestricted ways. And that should give us, 91. Okay. So whichever way you prefer, any kind of combinatorics with restrictions can generally be done either of those 2 ways, right? You either sort of do it from the bottom up, where you just sort of color within the lines and figure out all the different allowed ways, or the way I tend to prefer it, because it tends to be a little bit simpler, a little bit faster, is you just do the total unrestricted ways and then you subtract out the ways that aren't allowed. And that way it tends to be, I don't have to think of as many configurations. Okay. Any questions there? Okay, well, that's an hour. So yeah, this is essentially what our classes are going to be like. I don't know if any of you have already signed up for the class, but I do have a class starting soon. But yeah, we work through problems together. I do a little bit of like, here's the formula, here's the theory, here's the strategy, and then we're just working through problems together. And I'm here to answer questions, and either during class, after class, or via email or Slack. So yeah, let me give you my email. So you guys have it. It's just my first name, target test prep. And I'm going to stop the recording, but again, I have to hang and answer any other questions people might have. And thank you for joining.